Okay, good afternoon everyone. We are continuous on the same week. We are going to what mean by proof. It's like beginning information about what mean by proof. Proof are an argument that establish the truth of the theorem. So I need to establish is the theory is correct or no. If it's true, how can I say it's true or why I can say it's true? Logic tool for analysis of proof. We would use logic, we would use rules. So even logic or rules help me to reach the truth or the false of the theory by using proof. Besides, there are many ways to prove a theory. It's not only logic or rules, there is other way that can help me to prove. We have the direct proof as a theory. To prove are often in the form. As example, B give Q is true, or if P then Q is also true. So it's direct proof. Let's start with assume B is true. What we need to do is directly prove that Q is true to keep B, then Q is true. If Q is false, then B to Q is false. This is a direct proof we can say. As example, give a direct proof of the following statement. For all integer m and n, if m is odd and n is even, then m plus n is odd. So I need to have a proof. B is m, is odd and n is even, then I need to say m plus n is odd, which it's q. So we have a hypothesis, we have conclusion. I need to prove the first hypothesis, so we go to the conclusion. With the hypothesis, we can assume that m equal to k plus 1, which k belong to z. Also n 2k, which k belong to z, k2. Because here m is odd and n is even, so this is the way we can have m and n. Okay, also if we have m plus n, so we can have 2x1 plus 1 plus 2x it's not x, it's k. 2x1 plus 1 plus 2x 2k2, so we can have 2 here outside, and we have inside the brackets we have k1 plus k2 plus 1, so 2k3, that if assume that k1 plus k2 equal k3, which is belong to z, so 2k plus 1, which is m plus n, which is odd, because any 1 plus 1, any side or any number plus 1 will give me the odd, so we reach the conclusion. Okay, another example. Prove that all integer n for n square plus n plus 1 minus 3n square is a perfect square. If n is integer, we have this side, the one that he need me to prove it. So here we have 4 outside the practice, we can have it inside, so have 4n square plus 4n plus 4 minus 3n power 2. So here minus plus, we still have 1 because we have 4 plus minus 3, so still we have 1, then 4n plus 4, so we can have it in this formula, which is perfect square. since n is an integer, n plus 2 also is an integer, so we can have n plus 2 power 2 is a perfect square. This is direct proof. I need to disprove using the counter example. Disprove if for every n belong to z positive, we have 2 power n plus 1 is a prime number. Okay, let's go. N equal 1, 2, 3 and go on. We find that n power 1 plus 1 equal 3 is prime. 2 power 2 plus 1 equal 5 is prime. And 2 power 4 plus 1 is 17 is prime. And go on. However, as counter example, n equal 3, which 2 power 3 plus 1 is 9. It's not counter, it's not prime. With the counter example, so we disprove the theorem. So disprove, that means it's not correct. So since we have 1 is not correct, so we can disprove the theorem that it's not correct. Use direct proof. Show that if n is odd, then 2n plus 2 is odd. This is the this is yours to do it. Okay, the second way can we prove use contradiction. We want to prove that p to q is true. If I have p, then I have a q is true. Start with p is true. If p to q is true, then b not q is false. So if we prove that b to not q is true, we can reject the theory p gives q is true. So I need to prove that this is false, so we can say the theory is not correct. This is what we call it contradiction. Okay, by contradiction, prove that for every n belong to z, if n power 2 is even, then n is even. So p, which is n power 2 is even, qn is even, not qn is odd, because I need to have the contradiction. So I have q, the contradiction, q is even, the contradiction is odd. Because of p, we can write n power 2 equal 2k, which k belong to z. Because of not q, we can write 2 equal 2m plus 1, which m belong to z. So not q is odd, so we can write it in this formula. So if we start, if b, then we have not q is true. So n power 2 equal 2k equal 2m plus 1 power 2. So we have 4m plus 4m power 2 plus 4m plus 1. So we can have it in this formula. After that we will take 2 as a common factor between these two member. So we still have 2m power 2 plus 2m. So 2n 2 power 2 equal 2k is not even. So the results show that b, if b, then not q cannot be true. by contraction we prove that PQ is true. So by contraction mean I will try to prove the contraction or the nation of the theory. If I prove it, that means it's not correct. If I not prove it, that means it's correct. Here I try to prove the false, but I couldn't. That means it's true. We call it contraction. If we have 2n plus 2 is odd, then n is odd by contraction. Also, it's yours to do it. Recall that B give Q is equivalent to not Q to not B. Instead of showing B to Q directly, we can do an indirect show by not Q then not B. So if not Q then not B is true, then B to Q also is true. Irrational numbers are all the real numbers which are not rational numbers. So for all x belong to R, if x power 2 is irrational, then x is irrational. You need proof. So proof by contrapositive, here not the contradiction, here extra positive. So here instead of direct proof, we prove if x is rational, then x power 2 is rational. If x is rational, so x equal a divided by b, where a and b belong to z. So x power 2 equal a power 2 divided by b power 2 is rational number. By contrapositive, we prove the statement. So since we prove the contrapositive, so we can have the negative for this statement. Also, it's the exercise, you can do it, you should do it. Proof by case. When the original hypothesis naturally divided itself into various cases, for example, when the hypothesis include x is a real number, we can divide the cases for many cases. X is positive real number, x is negative real number, x is 0. Sometimes the number of cases to prove is fine and sometimes is too long. It's belong how the example or the question itself. So we can check them all one by one. We call this type exertive proof. Exertive proof because it's from existation. Because we should prove each part until the end, one by n. Prove that for every real number x smaller than x, okay, we have x is real, positive real number, so this is correct. For x also 0, we need to prove this. For negative, we need to have this. Combining all cases, we can conclude that every real number, this is correct. Why? Because we already have every part alone, so then we combine between each other. Because here usually should be positive number and 0 don't have sign, that's why. Then we go for the negative number. So here prove that 2m power 2 plus 3n power 2 equal 40 have no solution in positive integer. Note that 40 is not a large number and m and n are positive integer. Assume that n close to 0. So we have 2m less than 40 and m less than 5. Assume m is close to 0. So we have 3 in power 2 less than 40 and n less than 4. We can exclude the proof that we all have 1, 2, 3 here, 1, 2, 3, 4. Then we apply and we see the result. That means when m is 1, gives me the equation. When n is 1, give me the equation. Proof of equivalence. Some theory are of the form if P and if only Q. P if only Q. Such theory are proved by using the equivalence. So if I say I need to prove this side, I will go to prove the equivalent. That is to prove P if and only if Q, prove if B then Q, and if Q then B. So this is one of the rule that we have it before. So we prove the equivalent. Since we prove the equivalent is correct, we can have the other side that is correct. This is what we call it equivalent. By equivalent, prove that for every integer n is odd if and only if n minus 1 is even. We need to prove that if n is odd, then n minus 1 is even. If n minus 1 is even, then n is odd. We prove the equation number 1. If n is odd, then n equal to k plus 1. So n minus 1 equal to k plus 1 minus 1. That means instead of n, I will have 2k plus 1 is even. So we prove the second equation too. If n minus 1 is even, then n minus 1 equal to k. n equal n minus 1 plus 1. So instead of n we put k. 2k plus 1 is odd. So we prove that p to q, then q to b. So p if only if q is true. We prove both sides and the equivalent. And here we have like small short video to explain what mean by proof and what the way that used for proving. Thank you.